Hello everyone, today we will be creating a simple mesh deformer using SOP solver and wrangles. I want this to be a VEX exercise, so we will use intersect functions inside VEX rather than RAY SOP. And also I will give you a small tips and tricks about preserving your UVs while creating high-res meshes from low-res geometry. Now this is a low-res geoform that I found in Sketchfab. I will put the link down below so you can download it from there as well. And for this part, let's start planning things out. So for this model, so what will we do? Actually, after importing, of course, import session, I want to create my ground and then my animation. Now I want this animation to be procedural so I can decide on the run how fast I want this to go, and I want the option to slow it down or speed it up. Now for this procedural animation we will need a location animation first and then rotation. Now this is contradicting the real world. So in the real world, if you have a tire, it rotates, and how much it rotates actually affects how fast it will go. But this time, as a simpler explanation, we will use it vice versa. So we will change our location first, and through that we will drive an expression that rotates us perfectly on the go, so we don't have to play with keyframes, etc. Now after this animation, what will we do? We will prepare our mesh preparations. Low res to high res, and after that, first we will create still frame deformation as proof of concept. So we will just look at what functions we will use, or the RAY SOP actually, we can look both of them and see the differences, how we can use both of them in a still frame. Then we will implement POC, proof of concept, inside the SOP solver. This is for preserving our mesh, to preserve not our mesh, preserve our deformation. Now this will be our guideline. I just want a screenshot of this. Let's just keep it here. Now we will tick these as we go. We can start off right off the bat. I can close this, hide it. Okay. Now in Houdini, of course, you can create this, but I just created a simple mesh. I imported my tire that I got from Sketchfab, as most of the other DCCs use centimeters as their main unit, but Houdini uses meters. So I need to scale it off in 1 to 100, you can see here, to get it in a real scale. Now after that, I'm just deleting some attributes because I've imported an FBX, and these FBX rotation, translation, and other attributes that I don't want them. So I'm deleting them, and I'm just using a match size node to put its bottommost part to 0, ground 0. And of course I just got a grid. I remeshed it and used the mountain sub to create my deformed ground. Now as we have our base geo, what will we do? Let's start. Now first of all, I want to create my animations, right? Let's check our checklist. So actually we have done nothing yet, but I've started early, so I imported my mesh, the ground is done. Now the animation, let's go. Now for the animation, I will just get a transform node. Well, as these will have expressions and animations and will be important for me, of course I will rename them anim location and color code them. I use my animated ones in green. So anim location, what can I do? I will just use a simple time expression actually. I want to move in minus z direction, so I will just come here and write minus $t times 2. Let's see. Now what will this do? In every second, in every 24 frames, my tire will move 2 meters. You see? 2 meters. And every second. Let's take it like this. Okay. Now I want to give an animation to this actually. How can I do that? I might use the same transform node, but I want them separated because you can use different pivots or different rotations, etc. So I want to show using different ones. Now we will get a transform node. Let's rename it real quick. And rot for rotation and color code it. Hell yeah. Now for our rotation, let's just do a quick math. So I will come to my notepad, just new page, and actually for showing this off, let's get a screenshot of our sphere. So because I can't draw a perfect sphere. Now let's say this is our tire, right? I just want to put the ground here. You see, let's say we move this much, and we will name this distance x. You see, we moved x much, and this is my new location. Well, I also can't draw a perfect sphere again, so this will have to do it. Now in this, if we look at it mathematically, we can write that our turn count, so how many times that I rotated a full circle, turn count is equal to my distance, how much I moved, my distance divided by my circumference. Now this distance is actually, I created this in the animloc node, right? Animloc node. So I have this data, but how can I find my circumference? Now actually we can use a very simple mathematical equation again. So I think you have seen this in high school or earlier. This mathematically means pi multiplied by my diameter. It gives my circumference. Now I can reach to pi, of course, but how can I find my diameter? This is actually, as we are dealing in a circular manner and we don't have any additional data, the top point of y of my bounding box and bottom point of it. This distance, the difference between these, gives my diameter. And we have single functions for that, single expressions for that. The top point is represented with $y max, and the bottom part is $y min. And the difference between them is my diameter. I can multiply it with pi to find my turn count. How many turns did I take? And of course, at the very least, we will need to multiply it with 360 because one whole turn means 360 degrees. And so let's start doing that. Now in my anim rotation node. So first of all, I need to get my pivot to my centroid. What do I mean by that? In the anim rod, if you press enter in here, you can see your handle is in the origin. This means in your pivot transform, it's 0, 0, 0. If you rotate it, it will be rotated from that pivot. Now this is not correct for me. I want to use my centroid. What can I do? I can translate this pivot to my centroid with, again, simple functions, not functions, expressions. $CEX, centroid x, is my x value of my centroid. Now in here, $CEY y, centroid y. And at last we will get here right $CEZ, and our origin, not origin, our pivot is translated to our origin, our centroid. Now if I rotate it right now, what will we see? The correct rotation, right? So pivot transform is okay. Now I want to write this rotations x. As I said, what we need our distance, this data. Well, I can write the same function here, but if I want to change my speed, I need to change in here and in here, and that's just putting more steps in my way. To prevent that, I can simply copy this parameter, copy parameter, and come here, just paste relative reference. Now let's see what this does. Now I will just amplify it. Yes, you should be seeing this. Now, what does this do? It reaches to this node's parameter, TZ parameter. What is TZ parameter? If you hover your mouse on names of the parameters, you can see them: TX, TY, TZ. You might not be able to read it. So TZ is my translate Z, this. But of course not these nodes. We will reach in NMLock, location animation transform nodes, Z translate. So we are getting that at the start of it. So we have the distance. After this, what will we do? In our equation, we are right. Let's just put it here as well. So we need pi times diameter. Now this diameter is, let me just write it here. This diameter is also my y max minus y min. Now let's write this. I'm just getting there again. Okay. Now I will put another parenthesis for this, and I will write $pi. It's embedded in the Houdini, so this pi, we get it right off the bat. Times, again, another parenthesis for this calculation, $y max. Again, this is just like centroid x. This is a simple function that gives the y value of maximum of your bounding box. So y max minus y min. Now this simple expression should do the work. Why are we getting a different? So we need one more parenthesis. Okay, now it should work. Okay, let's delete this and let's see what it does. Well, I'm not turning at all. Actually, a very small turn is happening, but you might not be able to catch it. Why is that? Because right now in my calculation, I'm just looking how many turns do I make. But in here I need to write some degrees, not turn counts. So in the start of it, I will just write 360 times my equation. So right now it should turn perfectly normal. Now, if you can miss it, I will just make it slow down with a few clicks and it should work. Yes. Now again, with this change of this expression, I can rotate as much as I want, and it will be correct. So everything is derived from this. So we can put keyframes here on the z-axis, or write another expression. We can use frame expressions, etc., and our rotation will be updated correctly. Now let's just put it again, times 2, and okay. So I wanted a little bit faster. Now after this, what should we do? Let's try our first simple deformation. Now I know that in my steps, no, I just want to look at it. Okay, now we have done this part as well, both of them. Now I'm just ignore this step right now, because right now I don't need it. First I want to create my effect. I want to try to create my effect. Then I will have the problem of little details, the due to I have a low res mesh, then I will try to make it high res. So I'm trying to emphasize experience the normal workflow. You might not be able to plan everything throughout, but as we are working in procedural environment, I can go back and forth anytime I want. So we are getting here first. Still frame deformations as proof of concept. Let's go. Now, first of all, let's use a RAY SOP. This is the actually mainstream way, so we can use this. And in here, you see it's all messed up. It's not the equation that I want. Why is that? Because right now, in the method, we are projecting rays. That's true. But direction from normal. So we are taking a direction from normal, and if it hits our ground, it just projected it to there. I can just give you a quick explanation over here. Let me copy it and get a new page, paste it out. Now, let's say this is my sphere, and well, I will just create a wobbly one, and this is my ground, right? Now, right now, that's the thing for us. Now, in RAY SOP, in its default way, it's just looking at the points normal. So you see, it's looking at this. Now, while your normals are projected like this, if it hits the ground, I mean in here, it moves this point from this point to there. If it doesn't hit like this, it stays here. But it hits here, let's say this goes on in here, then it moves. These don't move as well because it's normal, doesn't hit our mesh. You see, this is that's why you get this. But if you take direction from normal to a vector, nothing changes because its default expression is using normal as well. So we're gonna delete it and just put an up 0 1 0. Now what happened? Let's see. Well, I want a normal node as well because it doesn't update my normals. Now let's see what's happening. Now, as you can see, we have a deformation, so it works. You see? Now, if I can just... So we are deforming a little bit. Right onto the ground as well. So if I merge it with the ground and look at them both together, now it's fine. Now, as it's in the ground, we don't see it, and this might be enough, but I want to preserve this deformation, and this detail is not good for me because I don't have enough geometry. If I don't have a point here or everywhere in between, I can push them down. There is no data to do that. So how can we do that? We can remesh our node, our geo. Now, for remesh nodes, you see this green dot here, green clock. This means your node is, this geometry is time dependent. It changes over time. But, and also, if you do anything here, so you see this, if its input is time dependent, it means it will cook every single frame. So if I put a remesh node here, it will cook on the first frame. After it moves, it will cook again and remesh again. And it's just an overkill of operations. I don't need to do that. As I said, we are procedurally working and we don't need to put our remesh or detailing parts after animation. We can put it below. So if I remesh here and animate after, I will be animating my remesh nodes and everything should work perfectly. So for trying out, I'm just starting from my mesh size node, okay? So I will just put a remesh here. And let's see. So this is very few detail, just 0.5, maybe 2. Okay, now that's better. It only looking for the point counts, of course. As a point count, this detail might be enough for me. But I have a problem. My UVs are all messed up. Although I might not see a problem if I use my UVs. If I don't use my UVs, you can see this, it's okay. But in the rendering phase, my textures won't be usable, or I can't use another outsourced noises, etc., because my UVs are distorted. I need to use a hard edge group. Now you see this hard edges group. What does it do? It's if the edge group that you given stays still, and as there won't be any middle points between them or any deformations throughout that edge, your UVs will be preserved better as well. Also, as this is a common issue, you don't have to create a group and select all of them. I explained like that in my Turkish tutorial actually, but you can have a much simpler setup. In here, in your remesh node, if you have a UV unwrapped geometry, you can just click this harden UV seams. If your UVs are unwrapped correctly, it will happen in the hard edges, and you can see this, it just sits still, and my UVs are not distorted as well, so it works. Now I can have a little bit more detail as well. If you have any other parts that you want to sit still in the 3D space, you can select them through hard edges group. But this toggle also solves our problems as well. Now let's add in our remesh, any location rotation, and it works. You see it rotates. Again, I will slow it down for now. Yes, and my UVs are not distorted as well, so I can use my textures in the rendering. Now let's see what happens after I give enough details. You see, we have many more points projected on the ground, so if it's preserved, it will be much better. Now we have used our RAY SOP, but I want to show you the VEX intersect function before we are going into the SOP solver as well. So I'll just get a wrangle. That's my 0 input, that's my first input. Let's open it up and name it RAY. Now in this function, I will just look at the intersect function, right? So first I will open its help page. Let's see what it does. Oh. If it doesn't open up, I will just select and press F1. You can search as well, but if you select the function, it opens directly its page. Now, in here, let me just magnify it a little bit. Now you see in here it says this function computes the first intersection of a ray with a geometry. Now what it takes, we will use this part. It needs a geometry to hit. So again, our ground geometry, I mean. So where will I look for my hits, intersections? Where my ray will start from, my origin, and where will it go? The direction. So this is the up vector, this is our position. But there are two more variables here, and before them there is an and symbol through yellow one. Might not be visible, I'll just get it here. And this in Houdini's help page, if you ever see a variable with an and symbol just before it, this means it's overridden. If this function works, this will be something else. No matter what it's in, before I put it in this function right here, don't matter what it is, it will be overridden if I intersect. If not, it will stay as well. Of course, this UV too. Now let's check what it is. Put down below. Okay, you see here in the help file it says if the ray intersects a primitive, this variable is overwritten with the intersection position in the workspace. So this is my hit position. Where have I hit? And this is my hit prim UV. In Houdini we have UVs of course, but also prim UVs, procedural UVs that specifies a very specific position on a primitive through a vector. Now, just like curve view attribute actually. Now, I can create this, but as I need this to overridable vectors. First, I need to declare them. So let's go. And the vector hit pose, hit position, and also hit prim UV. I'm giving simple names as RAY SOP. If you have used it, you might not, so you don't get confused. Also, intersect function returns an integer. That integer is the prim num of what we have had. So it's named hit prim. Hit prim, it's an integer hit prim is equal to intersect. First geometry, we don't have a group. Our origin is position, direction is 0, 1, 0. But in here, I recommend that you crank up the length of this ray. Let me just explain it here. Why doesn't it open? Okay. Now, you see this hit prim intersect. You see this? Now, in the ray SOP, the value of this ray doesn't matter. You just give a direction. But in here, it actually does. So, this intersect function will shoot a ray through 0, 1, 0 from our position for every single point. But if it's short, if it's 0.01 or something, it might not reach anywhere. So function again doesn't work. In that direction, there is a geometry, but your ray is just not long enough. So I'll just create 100, 0, 100, 0 length geo, and then I want you to overwrite by hit pose and hit prim UV. Now we can just write them on attributes to check what is what. So let's go. Let's do that actually. E at hit prim equals to hit prim. So I can show you very quickly what does it do. Hit pose equals to hit pose, and hit prim UV is equals to hit prim UV. Now let's say accept. Let's open our spreadsheet down below. Now you see here in our hit prim, if it's -1, it means we haven't hit anywhere. You see this, it might be this one as well. So only the points below ground, only this intersection happened that hit prim changes, you see. But these are very odd numbers. 26,087. What is it? It's the primitive number of this ground's prim. You see, where does that ray hit? This hit prim gets the prim num of this geometry. Now hit prim UV, as I said, it's a parametric UV, but hit pose is here. You see, if hit prim is 0, hit prim is -1, this is same as our position. If it doesn't hit anything, it overwrites with your point's position or origin. If it hits, it changes to that hit's position. Now, we haven't rayed anything. You see, none of the geometry has changed space because I haven't override my position yet. Now I will delete this. V at P equals to hit pose. Now you see this is exactly this. Now I will just show at you now. You see these are exactly same. So we're using the same function fundamentally. But we have a few more functions here. We can use a different origin and direction. So I like the intersect function a lot. And this is a VEX exercise. So we'll be using our ray named red. Now, as we have used our proof of concept. I'll just get this. I want it a little bit more organized. So I'll just get this something like this and get these kids to side. Now, as I said, we will implement these raying projecting execution in a SOP solver, and we will preserve our rotation. Now let's go with solver SOP. Now, while working with solver SOP, if you go in and try to watch everything inside here, you might get a messed up viewport. It doesn't crash anything, but it shows the wrong thing. So I like to split my viewport in this regard at this stage. So I will first split them up left and right, left and right. Now I will link these three together in one. You see this pin? I will make this one, and this two, one as well. So these three are linked. And I will make these two so they don't correlate and change the viewport. In here, whenever I want to watch something, I will just push reset simulation and watch it. In here, I can go into solver SOP without changing my viewport. Now, we can get this a little bit slower as well, smaller as well. Let's get this thing going. Now, what will we do? First, let's create our ray first. Now, as we have created here, this ray, this function, I will write it here again. And name it ray. So we will be using our pre-frame data here only to preserve our deformations. So it's not needed right now. So let's just get ray and put it to output. And just open its eye here as well. Okay. Now in here I will write mostly the same function. So vector, hit pulse, hit prim UV, int hit prim, integer hit prim. So of course I can copy paste it, but as this is an exercise, I will just rewrite everything again. I will look the first primitive, and V at P is my origin. I want to go 100 meters up. If I hit, I stop, of course. It's the first intersection. And also I will overwrite hit pose and hit prim UV. Now for showing you, I use the single, of course, this snippet editor or here, but actually if you get your external editor to Sublime Text and get VEX, you might work even faster or in a more intuitive way. But let's keep on going like this right now. Now if I do this, so nothing changed, right? Let's set our position. V at P is equal to hit pose. Let's just reset and watch. Now you see nothing changed. Why nothing changed? Because this has no difference than this. I'm using a simulation, but I'm not getting the power of simulation. I'm not using my previous frame data. I'm just raying what is coming with what's coming. I'm not using any cumulative data. I'm just using same thing or each frame on its own. So in order to do that, I don't want my deformation to be at this point. I want to deform at last. I just want to store where I want to go. How can I do that? I'm just going to create another vector named direction in my attributes. That will be my hit pose minus V at P. So I want a direction in my points to show where they will be moving. Now just open that visualizer. Well, as this is my also an R&D project, my visualizers are ready. If yours isn't, you should just edit here, make it marker and vector. Now you see only ones that are getting intersected. Let's just template this. You see only that ones are getting intersected, getting a direction attribute. Now also, you see, I'm just thinking ahead. if while I'm turning again, I can preserve this, that's okay. So how can I preserve it? I will just put another wrangle here and just put it here and just say preserve, just say v at direction equals to point, as this is a point attribute, first input direction attribute, my point. Well, this should have worked, but it doesn't. Why it doesn't work? Because first of all, I don't have a direction attribute in my previous frame. I'm just creating it right now in here. So as the previous frame doesn't have it, it can't update it. This one is empty on the first frame and it loads empty. So in the next frame, it gets the loaded empty one and it goes on like this. So it doesn't work. If I just create my direction attribute before here, yes, it will be collecting that data. But again, only that data will be preserved. I need to checker. I need to check something to see if I'm intersected, because I want to preserve direction from before. If I'm not intersected again, if I'm just getting into the ground, if I'm just intersecting with ground, I should be moving there. That should be my direction. I don't need to preserve anything. While I'm not intersecting, that's when I need to start preserving what I have. So for that, in that regard, we need a checker. So that checker might be a distance. If I've been impaled this much, and in the previous frame, if I'm not impaled at all, so this is my new impalation, right? But if I'm not that much intersected in the ground in this frame, then I should preserve the last one. If it sounds complicated, trust me, it's not. Maybe I just couldn't explain it enough. Now this is a float, actually, float distance attribute, length of direction. Now we will use this distance as a check for if I'm getting intersected. If not, preserve. If I'm intersected, this intersection should be my direction. Now let's look at it. First of all, I need the previous distance, and that's named point1 distance attribute of the point number of me. Now I need a vector of previous direction. That's the first point's first input's direction attribute of point number of me. Okay, now we need to check things first, right? If my previous distance is greater than my current distance, I need to preserve who is intersected more. So if previous is bigger, I need to update myself. V at direction is equal to previous direction, and V at distance is equal to length. I need to update distance as well. If I don't, on the next frame this doesn't work. So I need to distance length V at direction. Okay, if this is not true, my direction is still me. Let's check it out if it works right now. Now you see we have our vectors here, and when I press play, yes, they are preserved, but there's also another problem. They are exactly preserved on their rotation. They don't rotate with me. They just look up, because first intersection was looking up, and they are always keep looking up. Now we can find different solutions to this. So there's more than one way to find solution of this, but I have a simple one for you. If I can find a way to see how much I'm rotating between two frames, you see between these two, if I can get that data, because I have those two geometries here, previous frame and current frame, if I can get an orientation difference between these two frames and rotate my preserved UVs, preserved distance here, this is my preserved ones, I'm getting the previous one. While getting it, if I rotate it with as as much as I'm rotating, then this direction should be working as well. How can I get that? Actually, we have a very simple node to do exactly that. Extract transform node. So extract transform node takes two inputs and creates a transform attributes. You can change different ones. Transform attributes looking to both of them. So for target geo, my target is my current frame and reference is my previous frame. Look to my previous frame and write our transform differences in an attribute. If I look at this attributes, wait a minute, yes, my camera is back on. So if I look at the attributes of extract transform, I'm just using standard instance attributes. You see there's an orient. So it looks throughout the geometry. So if I deform it here, it will mess it up. So we will doing the deformations outside. But it looking throughout both of geometries and creating a transform. Orientation differences here. So it looks the reference geometries and target geometries difference and writes an attribute according to that. I have that right here. Now what can I do? I can just put it here on the third input, and here just add the vector 4 orient, let's say orient is equal to 0.2 orient. As there is only 1 point, I need to write 0. Okay, my camera is getting lagged off. Now, if it stays, it stays. We are getting on the end right now. Okay, so after doing this, I need to rotate this direction, right? If you are using a vector for its quaternion, it's actually rather easy, very easy. We will just use a qRotate function with orient and previous direction. Now, before just seeing that, let's just open the help page. You see, rotates a vector by a quaternion. So this vector is rotated by this quaternion, and this quaternion is determined with the difference of my previous and current frames transforms. Now this should work perfectly. Let's see. You see, they are looking inside, they are rotating with me. With doing this, you don't have to get stuck on a single axis. You can make a rotated tire in this manner. It will still work. So I want to check out my deformations, but if I do it here again in the SOP solver, as my previous frame data will be changing in its positions, my extract transform might get messed up. So I don't want to do it here. I have an attribute already. I can just, while after the SOP solver, after preserving this attribute, I can just come here and write a wrangle and just set P. V at P plus equals V at direction. Let's see what happens. You see, our deformations are preserved throughout. Now, if you move too fast, let's just show it like this. If I just put it right here, if I'm moving too fast, you see there's a stepping going on. Why is that stepping happening? Because we are turning too much in a single frame for correct calculations. We are turning too fast. I just need to crank up these sub-steps because I'm doing my calculations that are not dependent to sub-steps. I just need to before frame, and I'm just using that. Everything is procedural, nothing is handwritten, nothing is hard-coded. Thus, sub-steps will only help me. You see? It works very smoothly. Now, as my camera is getting logged off frequently and we are at the end of our animation, end of our FX, I will end this one here. I don't want it to be too long, and I hope you learned some things. This is a very simple setup, just explaining it longer than I anticipated, but once you get a hang of this, actually this part is okay. This is not that hard, you can do this. If you do it 3 times, you get the hang of it real quick. But this extract transform SOP and using that transform attributes to do something else. You see this with a target and a reference. This node is really powerful for correlated geometries work, and you can make magic with this. So I will just cut my blabbing here. Thank you very much for watching. I hope you learned something new today. Have a nice day.